So part B now, we want to show that f of g of x does not exist. Okay, so you're just going to draw this round different ways. So if we've got f of g of x, then it's a g of x that's going to be performed first, and then followed by the f of x. Okay, so let's do that round this way. So start off again with x. Then here, instead, we're going to be doing g of x first. So we form function g first. And then we go in here of f of x. So this is going to be f. So therefore, we're starting off with the domain of g. We get out the range of g, the second part of the composite function. We feed in the domain of f. This will be the key to deciding if it exists or not. Now, we know from the question that it's not going to exist. So let's prove that. You see here we got the range of g. So the range of g was -3 to infinity. It's -3 to infinity. The domain of f was 2 to infinity. And their domain of g was R. So therefore, if we look at this, we can prove that it does not exist. Now the second part of the composite function only works for values between 2 and infinity. But what's happening here is the first part of the composite function is producing values. And you'll see that there's values here that are not going to fit in the domain of the second part. Hence, it's going to stop it working and then it won't exist. So for example, -3, if you get -3 out, it's not going to work. The composite function won't exist. If you get 0 out, if you get 1 out, all of these different values that will stop the composite function existing for the second part. So what we can state there then is, because the range of g does not lie within the domain of f, there's values that you're getting here that are going to stop the second part working. Therefore, it does not exist. Okay, so it's not defined, this composite function. But what we can do, which will be the next question, is we can state the largest domain of g so that f of g of x does exist. So to make it exist, we need to stop getting these values like -3, -2, -1, 0, 1, for example, some of the values that are stopping it working. So for this second part to work, this second part only works for values between 2 and infinity. So what we want to do is say that, well, the range of g, as long as the range of g is greater than or equal to 2, then it's going to exist. There's not going to be any problems there. Now, the range of g, we get the range of g by using the function. And the function g is x squared minus 3. So when you're performing that, we know that x squared minus 3 must be greater than or equal to 2. And we want to solve this in equations. So first of all, we want to make it equal to 0. So if we take the 2 over to the other side, we'll have this. If you're solving an equation, certainly it's not linear, and you should sketch it. You'll see that we want x squared minus 5 here. So x squared is going to equal 5, x will equal plus or minus root 5 will be your intercepts. And then we're looking for the section where it's greater than or equal to 0, so it would be this section here. So therefore my domain now of h of x is going to be negative infinity up to negative root 5. And that will include, because 0 is fine, or root 5 up to infinity. So you see, it's these values here that are going to give you the values where it doesn't work. So example, if you take 0 here, and you sub 0 in here, so you'll have x squared minus 3, so that'll be minus 3. That's giving you a value here, you see, that doesn't work here, because minus 3 won't fit in the domain of the second part. So by restricting the domain and missing out these values here, that's going to stop you getting all the values that don't work for the part f there. And the last part is to state the range. So we know this is going to be the new domain here, okay, of the function. So that's going to be the domain. So basically here, when we use this domain, then what's going to happen is it's just going to produce values from 2 to infinity. Therefore, the domain of f will just be the same, 2 to infinity. So that means that if you look at the graph of f, it's just 2 to infinity, so it's everything. So it'll actually just be the same as the range of f. And the range of f we know is negative infinity to negative 1. Okay, so the range of h of x, in this case, because you're just going to have, this will be the only values that you've got here, so that's just going to give you the range of f, which is negative infinity to negative 1. Including.